Lesson 2-2, Scales and Intervals, and in this lesson you learn to choose appropriate scales and intervals for frequency tables. In the last lesson 2-1, we learned how to create frequency tables, and we also understood what frequency tables are for. Frequency tables are part of a branch in mathematics under statistics, where it organizes data so that we can better analyze it, okay, and interpret data for our own purposes. Let's take a look at scales and intervals in 2-2. And in here, for her history project, Margaret is investing the early state legislature of Massachusetts. She uses an atlas to find how far each country's seat from the capital, Boston. The distances in miles are 65, 134, 37, 85, 22, 101, 90, 102, 7, 105, 2, 41, 28, and 42. How can Margaret organize this data so that it's easier to study the distances? This problem will be solved in example 1. If you're wondering what this gadget is, this one right here, okay, it actually has it's like a pen. It's a digital distance reading instrument that you put on an atlas. Of course, obviously today it's not anymore viable, since technology has improved in such a way that we do not need this type of a gadget. Anyway, it has a roller underneath, and as you roll this this instrument across the map, it measures the distance in this little LCD screen right here. Okay, so by rolling this little gadget here, you can measure the distances from, let's say, one point to another point by just rolling that pen. Okay, obviously now that's easier to do with the advent of the internet. All you need to do is type in, okay, type in the two distances on Google, and you can find the distances on Google Maps too. It's so easy to find distances between 2 points. Okay, so if you're just wondering what this is, okay, it's an obsolete gadget that we don't use anymore. But onwards to what we're trying to do in this math lesson, this will become useful for us. Okay, so what is Margaret faced with? Margaret can group the data in intervals. To do this, she needs to determine the scale for her frequency table. The scale must include all of the data. So here it basically defines what the scale is. The scale is including all the data that Margaret has gathered from 65 all the way to 42. Intervals are not readily defined, so I defined it for you. Definition of an interval: all the numbers between two given numbers. Okay, we'll analyze that definition further in example 1. Let's take a look at example 1, and let's see how we can solve Margaret's problem. Referred to the beginning of the lesson, organize Margaret's distance data into a frequency table. Step number 1, okay? Determine the scale. Since the data includes distances from 2 to 134, begin with the 0 and end with 140. So if you look at the data of Margaret, the least number of miles would be 2 miles, and the greatest number of miles would be 140 miles. So your scale should be 0 to 140. Why not 2 to 140? You can probably do 2 to 140, but 0 to 140 will be more accurate. Okay, simply because we want to start with nice whole numbers and end with a whole number. Since the highest number is 134, we can either do 135. 140 is probably a better value because it's a nice whole number. Okay, after determining the scale, let's determine the interval. Okay, determine the interval. To keep the number of intervals manageable, choose an interval of 20. Okay, so when you say intervals of 20, that means 0 to 19 would be one interval. 21 to, well, 0 to 20 can be an interval. 21 to 40 can be another interval. 31 to 60 can be another interval. That's what it means when it says intervals of 20. The two numbers, remember the definition of an interval? All the numbers between two given numbers. In this case, 0 to 20 are the two given numbers and the numbers in between. Okay, so that's a good interval. And finally, step number 3. Okay, make a frequency table. Now that Margaret can see the number of county seats in each interval. Okay. Remember also that when you create an interval, all intervals need to be equal and not overlap. And let's take a look at the scale. The scale is 0 to 140. This is the scale right here. 0 to 140. And the intervals are 0 to 20, 21 to 40, 41 to 60, 61 to 80, and so on and so forth, all the way to 140. So if you notice, there are 1, 2, 3, 4, 5, 6, 7 intervals for this. And another good way to analyze this is that when you are determining intervals, make sure you have, okay, at least your interval should be 5 to 7. Okay? So you have to have 5 to 7 intervals. In this case, we have 1, 2, 3, 4, 5, 6, 7 intervals. So that's good enough to work with when we are trying to organize our data. Okay? And after doing that, we perform our tally marks. From 21 to 140, there is only one value that goes into 21 to 140, and that is 134, and that's the reason why there's only one tally mark. From 101 to 120, there are 3 values. Okay, so from 101 to 120, that would be 101, 105, and 102. Those are the 3 tally marks, and so on and so forth, all the way down to the last interval of 0 to 20. Actually, that's the first interval. And if you count the number of frequencies for each interval, these are the number of frequencies for each interval. Okay? And that's how you create a frequency table for Margaret's data. Let's take a look at example number 2. The scores of the Glencoe Scholarship Golf Tournament are shown below. 74, 87, 88, 97, all the way to 81. Determine an appropriate scale for the data. Make a frequency table for the data. Okay. If you look at letter A, a scale from 66 to 100 is appropriate because it includes all of the scores. Remember, when you create a scale, it has to include all the pieces of data. In this case, if you start from 66 and end 100, okay, that would create a good scale. Now, why not use 0? Because there is no value that is less than 60. So using 0 to start your scale would not be a good choice. Okay, since the least number would be, and in this particular group of data would be 67. Yes, 67 is the least, and the greatest number would be 99. Okay, a scale from 66 to 100 is appropriate. Okay, and then when you're talking about intervals, remember that there should be at in between 5 to 7 intervals. Okay, so after that, we make a frequency table for our problem. And since we are our scale is from 66 to 100, okay, an interval of 5 would probably be appropriate. And if you notice, 1, 2, 3, 4, 5, 6, there are 7 intervals. Okay, so if you use interval of 5, the first interval would be 66 to 70, second interval 71 to 75, and so on and so forth, all the way to 96 to 100. Okay, and then using the information that we have here, okay, we start creating tally marks. From 96 to 100, there are 2 of them. 91 to 95, there are 2. 86 to 90, there are five of them, and so on and so forth. And we simply write down the frequency of each, okay? Each data as it appears in its interval, okay? And that's how you create your scale, your frequency table using scales and intervals, okay? Okay, let's do some more examples on this. When you make a frequency table, sometimes it's easier to group the data into intervals. The total size of the scale, the total size of the groups is the scale of the frequency tables, and that's another way of looking at scales and intervals. Definition of scale, another definition, the total size of groups is the scale, and you separate the scale into intervals. Okay? Now look at this. This is what I'm talking about. Choose a scale that includes the least number and the greatest number. Choose an interval that will give you a manageable number of groups, usually from 4 to 7. I'm not, okay, so let me correct myself. Instead of from 5 to 7, 4 to 7 would be good too. But 5 to 7 is also appropriate in this case. Make sure all the intervals or groups are equal and they do not overlap. We've discussed that before in our definition. Let's take a look at some examples. Example A. Name the scale in the interval in this first column of the frequency table. 3 throws, 16 to 20, 11 to 17, 6 to 10, 1 to 5 are the intervals. Okay? So, in this example, our answer would be the scale goes from 1 to through 20. Okay? Each interval has 5 scores in it because from 1 to 5, there are 5 numbers in between. Okay? 1, 2, 3, 4, and 5. From 6 to 10, there are also 5 numbers in between, 6, 7, 8, 9, and 10, and so on and so forth. So the interval in this case is 5. Let's take a look at B. Here are a number of free throws made by a third period gym class, 17, 2, 10, 4, and so on and so forth, all the way to 4. Complete the frequency table started in example A. Okay? Add 2 columns to the table, mark tallies for each interval, then write the frequencies. This is what it means. So the free throws now, okay, and we use the intervals that we have here. Our scale is 1 through 20, and these are intervals, 1 to 5, 6 to 10, and so on and so forth. Tally marks would be 2 from 16 to 20 because there are only not 2 numbers, 2 pieces of data that are in between 16 to 20. And there are 6 pieces of data that fall into the interval of 1 through 5. And that's how you create your frequency table in this particular example. Okay? Okay. Let's try these together. Choose a scale for data from 3 to 32. Okay, hint, your scale must include 3 and 32. For this particular exercise, you can pause the video and do it on your own. Okay, and trying to figure out how you got to the answer. Second question, how many different whole number scores are possible in an interval from 25 to 30? Again, another hint, write each score 25, 26, and so on and so forth, and count how many, or subtract 30 minus 21, and then add 1. Okay? Okay, so if you choose a scale from 3 to 32, Uh, what's a good scale to choose? Good scale would probably be, since 3 is close to 0, a good scale would be from 0 to 35. That would be a good scale. How many different whole numbers scores are possible in an interval from 25 to 30? Okay, so 25 to 30, simply count the first number, 25, 26, 27, 28, 29, 30. So therefore, from 25 to 30, there are 6. Okay, there are 6 possible whole numbers that go into 25 to 30. Okay, let's look at the practice. Again, do this on your own first, and then uh, uh, pause the video, do this on your own, and then just click on play again. So choose a better scale for the frequency table for the set of data: 1, 3, 8, 9, 12, and 20. Okay, so scale would include all of them, and since the least number is 1 and the greatest number is 20, a good interval would be, okay, 0 to 20 or 0 to 30. A good interval would probably be 0 to 30, just in case, to be safe. Okay, but again, if you choose 0 to 20, that would also be fine, since 20 is included. Okay, now in number 4, choose the best interval for a frequency table for the set of data: 10, 32, 64, 80, and 96. If you use intervals of 3, what would happen? Okay, first, before we talk about intervals, we need to create a scale. So since the least number is 10, the greatest number is 96, a good scale would be 0 to 100. And if we do intervals of 3, there's going to be more than 7 intervals, so this is not a good choice. Okay, if we do intervals of 10, there would be 10 intervals. Again, that would not be a good choice. But if you do intervals of 20, there would be 5 intervals, and that's the reason why you want to choose 20, because you will only have 5 intervals. Remember what we talked about when you talk about intervals. Okay, it has to be right here. Okay, usually from 4 to 7. Okay, or 5 to 7, whichever you want. So those are the examples. And finally, come to the end of the lesson. On Google Forms, type a summary of what you've learned by responding to the objective of the lesson, and type a question you might want to ask in class about this lesson. Thank you.